Introduction, Materials, and Procedure. A Stomp rocket, which is what we'll be using in this lab, uses a compressed air bladder to launch a lightweight rocket, typically a plastic or a foam tube, into the air. They come in a variety of sizes. Larger ones can be jumped on, smaller ones can be hit with your hand. Select a Stomp rocket that can go high enough in the air so that the height is not easily measured with a meter stick, and that is in the air for a long enough time so students can time the flight with a stopwatch or their phone. Students will use the time data to find the rocket's initial velocity and the height of each rocket, using the kinematics equations and the acceleration due to gravity. We don't need a lot of materials for this lab, just the Stomp rocket set up here. And this is the thing you press on, and this one you'd activate by stepping on it with your feet. And here's the rocket that goes up in the air, and you'll need a stopwatch or a phone. Larger Stomp rockets should be taken to a field or an open area. Set up the rocket per the directions on the package. Practice a couple of stomps to make sure it is working properly. Make sure it goes straight up. We just want motion in one direction, one dimension. Students will time the entire flight of their rocket from where it leaves the ground until it hits it again, and that will be repeated for each student in the group. We'll be using the measured time and g to determine the height in the air and the initial velocity, which is pretty cool. You're just measuring one thing, and you can come up with how high the rocket goes and how fast it was going when it was launched. If you don't have Stomp rockets, you can perform the lab by throwing a tennis ball into the air. There are a variety of Stomp rockets available. Some have bases that are more sturdy than others. You can use cable ties or zip ties to hold the base together more permanently. And that's illustrated right over here. Make sure the launcher is positioned straight up. Keep it away from trees and rooftops where you may lose your rocket. Students should work in groups of 4 to 5 so that each group can repeat the calculations 4 to 5 times. Here's the procedure for the students. Set the rocket up in an open area, and if you're just throwing a tennis ball up because you don't have rockets, be sure when you throw it up you know where your hand is when the ball leaves it, because when the ball comes down, you time it for when it passes where your hand was. It's not when it hits the ground. Using a stopwatch, determine the time of flight. You'll have one student stomping on the rocket bladder, and the other student will time the flight of the rocket. Repeat the process, one for each student in a group, and then fill in the chart with your data. Warning: these rockets can travel pretty far, especially on a windy day. Be sure to have extra rockets handy in case you lose some in trees or on top of buildings, but you shouldn't be shooting near them anyway. Do not have the students position their head directly over the launcher. You don't want any eye or head injuries. And students should not position a Stomp rocket to launch into another group or another student. Students should be looking up to watch the flight of their rocket. Group members who are not timing or launching should be looking around for other rockets coming down. Students looking up should not be moving around so that they don't collide with other students. Note that after many uses, the bladders can become cracked. Students should be instructed to stomp gently on the bladder to prolong its life. You can use duct tape to fix a cracked bladder, but it's better if it doesn't get cracked in the first place. An acceptable data collection table is shown here. All the students have to do to collect the data: fill in the name of the person who did the Stomp rocketing and the total time that the rocket was in the air from where it left the launcher to where it hit the ground, or actually where it passed where the launcher took off from, which is, well, maybe a half a meter above the ground. Click here to get a video where some students were performing this lab. It'll give you a good idea of what to expect.